All right, welcome to another lecture for Rolling Scope School. Today we have a basic security fundamentals 101, etc., etc. It's all about security. And your lecturer for today will be me, Mitri. And what we'll be covering is quite a few topics, but trust me, that's just like fundamentals and like the tip of the iceberg that there is in the security topic. So we'll start with security overview, what it is, even if it's like being like a captain, still what it is, why do we need it, what are the common ways that the industry defines security. Then we'll go into something like XSS. It's not the size, like extra small, but it's cross-site scripting. Sorry. Very interesting topic, quite malicious one, I'd say. Then we'll cover something that we've encountered already in our course called pardon the pun, cross-origin policy. So after that, we'll go a bit deeper into the web applications. A bit of back-end understanding would be required to understand this SQL injections topic, but still, even front-end developers need to know that it is what it is, and we need to be aware how to prevent that from happening. And then we'll finish with everything about Auth, or authentication, authorization, the best practices, and like in general, why we kind of bother ourselves with authenticating someone. And yes, of course, we'll have a Q&A session where you'll be lucky to have an opportunity to ask questions since you've came to the lecture in person. That's cool. So, security. There are several perspectives on the topic of security. We can say that security is just the application-related thing, where we assess, mitigate, and protect our software. We write code in a specific way. We engineer stuff in a specific way that it deems to be secure. However, security is a much larger idea of kind of like engineering software, not in terms of the software itself, but also for the processes around the software, delivery of the software, management of that software, management of the teams, etc., etc. Security is a vast topic, and we have best practices everywhere for all those topics in the security. But we'll be mostly focusing today on the basics of security, and since we are developers, not managers, not QA engineers, or not DevOps, we are mostly concerned with application security. And for us, application security is all about OWASP Top 10, which is a strange name, given that it literally means a wasp. Sorry for that. Yeah, and the OWASP actually stands for Open Web Application Security Project. It's a big kind of open source-ish project that researches and documents everything around security, how to assess it, how to mitigate some of the security vulnerabilities, and it is and it has been the oldest one in terms of the security and standardization of the security in the web. So people just tend to go to them for the consultation, for the materials, for the research, everything that is around web security is handled by them. So they at some point released what we see here, which is a top 10 document, which you can access by link. And that's just a list of the most common to date security vulnerabilities that people need to kind of address in their application on a daily basis. Let's actually go and have a look. Let me just pull it over. So yeah, this is how it looks. So it's just a pretty old website, and it has lots of topics, but the most important for us is this top 10 web application security risks. And it's just like an overview of what it is, but you can definitely go and have a look at inside each of them, have a more detailed view, some examples, etc., etc. So it's really nice thing to have, and most of the security professionals will be around this website a lot. Okay, so that's that. So whatever is written there should be addressed in any mature web application released into production. So yeah, it's a good way. We have this introduction lecture, and we start with the cross-site scripting attack. It might sound something like a hacker-ish thing to do, but it's actually a very common and kind of obvious thing that we need to implement in our websites or act against in our websites. And it's all about preventing someone from using the user interface that we provide or the data inputs that we provide in a way that we're not intending them to do. So whenever someone says XSS or cross-site scripting, always think about you as a user and the website, and someone in the middle between you and the actual website. And the website, and by website I mean website application, server, maybe some database, user interface, anything that stands in the middle or receives your data that was intended to the website by standing in the middle is cross-site scripting. So the image shows the most generic example of what it is to be to exercise the XSS attack on the website. So someone, presumably hacker, red team, as they called, injects some malicious script. There are a number of ways to do that, but let's pretend that it's just an injection of the script. And that script just stands there in the middle, not actually doing anything with the website itself. It does not do any harm to the user experience. However, whenever someone interacts with the website, the data, the victim, the user, is actually transferred either both ways or through the hacker, so that the hacker can actually store that data and do something with it. A very typical example would be authentication, a broken authentication. The victim authenticates in the website, providing the user name and password, and instead of going directly to the trusted website, the data goes through the hacker. Hacker sees that data and can either store the username and hacker, or the cookie, or the token, anything secure, or can actually prevent the victim from actually using the website, and then act as that person for the website. So the website will be assuming that the hacker is a user and trusting with everything inside. So that is a bad situation. And there are a number of permutations for the attack. So a number of ways we can do this attack. And it's not in any case like a ethical hacker course. It's just the basic security. So you need to understand just the basics of the cross-site scripting attack being someone there providing some code and making the website execute that code so that they can listen. How do we prevent that? So whenever we encounter a user input, this is a potential place where cross-site scripting can happen. Any user input, be it like an input field, select, or checkbox, or text area, or even the address bar, these are the ways the user can interact with the website, kind of like user input. So whenever we need user to physically type or insert or provide some data, we need to kind of go through a validation process. So the most strict one is that for every input, we need to allow only a certain data to be provided. So that's called an allowed list input validation. So that for the name, we won't allow to have a number, for example, or for the text area, we won't allow any bitmap of an image. So it's just a certain type or allowed list of data. Also, the hacker cannot just provide bad data or spoof that data or listen to the data we provide. The attacker can also insert some HTML, and that's for the sending of the user data to some other origin somewhere where the hacker stays. So we need to prevent that. So basically, it's a good practice to avoid HTML in any of the inputs, so that imagine like a text area would not allow any HTML-based text manipulations, bold inputs, large, less. So nothing of the HTML should be allowed, or it should be highly restricted, and there are ways that we can do that. But better safe than sorry, we can just avoid using HTML and provide some other ways to for user to do what they intend to do with HTML. All of that boils down to sanitizing anything that user supplies. So, and by sanitizing, I don't mean only getting rid of HTML tags and allowing only certain input. We need to make sure that that allowed input and that non-HTML input does not contain any bits or bytes or symbols or anything suspicious. So we need to sanitize for that. And by sanitizing, I mean pass that data, analyze it, and only allow it to go further if it's okay. And also use HTTP only flags for cookies. That's somewhat different from what we discussed by now. The HTTP only for cookies is the way that the old authentication worked, and the cookies were stored inside the browser somewhere safe, but they were still available from JavaScript. And if we fail to do any of the above, and the attacker can actually insert something into the website, inserting the JavaScript would allow him to or her to get the cookie from the website, and that is bad. And we need to tell the browser to kind of pass the cookie only to the HTTP itself, not to the random JavaScript code. So that's all about the XSS mitigation. That might be a lot, but bear with me, there will be lots more further ahead. So, CORS, cross origin resource sharing. We already mentioned that this is a mechanism that does not allow browsers to access domains that they're not supposed to access. And we know already that this is mostly inside the browser itself. So we can actually, we cannot actually control it since it's inside the browser itself, not on our end, so not in our application. But we do control some parts of it if we control the web server. So to summarize, the web server can tell the browser that the request that the browser issued can be done and is allowed. And the course was around for decades already, I think. And it was mostly for the resource sharing side of things, so that resources are only accessed by those who they are intended for. But from the security perspective, the courses rules should be strictly followed so that the application itself is not able to go somewhere or send their resources somewhere that they're not intended to send it to. So just imagine the web server sends some requests for the website it was not intended for, and that the whole thing is accessed by a different person, by a different browser. So lots of things can happen badly if we don't follow the cross-origin resource sharing. And this policy could be very annoying when you develop websites, but it is what it is, and you need to kind of oblige to the whole security perspective of courses. So what is so secure, and what do we need to do to secure the course mechanism? It is in place already, so you can't just disable it in the browser, but you can actually disable or misconfigure the course headers on the website servers. So to mitigate the course issues, the course security, we need to properly configure the cross-origin domain requests so that only a certain number of websites are allowed to access the web server. And also the configuration should contain a certain and very specific trusted websites. It should not be whitelisting everything by just providing the header with null instead of the actual names of the website. And also wildcards that say everything is permitted should also not be used, even if we are talking about internal networks. So whenever we make a request from different domains to the web server, and the web server should be the one to decide what to do with the headers of that request and of the corresponding response, we should always carefully think about what should be in the course headers. That is a basic thing, but it is a source of a lot of security vulnerabilities. The next one is kind of interesting. It sounds a bit like it belongs to the backend because we don't usually use SQL stuff on the front end. But still, as JavaScript developers, web developers, you need to know that there is a thing called SQL injection, and it's all about manipulating the queries that go into the database. So we know that basically the database interactions is, in terms of the SQL databases, database is just a kind of beefy machine that is kind of dumb. It just gives you or responds with the data that you ask it to respond, and you ask the questions, the queries, using a special notation, and that notation is nothing more than a string with specific words used inside that string. So what is an SQL injection in general then? Imagine that we are trying to create that string on the back end using some kind of data from our website. So imagine we need to access all the user data, and to access that user data, we need that we need to understand what exactly the data that who exactly needs that data, and by who I mean user ID, user hash, anything that identifies the user. So we kind of prepare the string on the back end, and we concatenate usually the user ID to that string, so that string is kind of a generic way, and the user ID is a dynamic value that could be anything for all the users that we have in our user pool, right? So, and that query is sent to the database, and the database just spits out the response with everything that we send it to. But since database passes that query, so it kind of analyzes what we send in that string, and it does everything it knows from that string to the dot, so very precisely, because it's a query. Imagine that instead of sending a user that dynamic value, we send another SQL string. So then in the backend, we concatenate both of those strings, and database ends up doing something nasty, maybe just removing all the data, or maybe exposing the data to a hacker. So the whole premise of SQL injection stands around the query construction. So we need to find a way to construct queries in a secure way, and we do that with prepared statements or parameterized queries, as they called. So a special notation that could be used on the back end that does not manipulate with the string directly, so we don't concatenate any user data to that string and send it raw. All we do is we provide some kind of a function, and that function will be executed by some application on the back end, and that application would construct the query for us, and it will do some kind of basic sanitization. So we just provide the values, and it constructs a string. We don't ever construct the strings ourselves, and that is kind of like relying on the security of that database access application or database access library. Another thing we can do is that we can use stored procedures or stored queries. So instead of actually doing dynamic stuff, we can execute something that is prepared already. For example, a list of users for a number of pages, also an option. And again, also from the web application perspective, so from the front end, we can start SQL mitigation by using, again, allowed list of input validation, so that instead of sending a user ID, hacker would not be able to send anything else, or some kind of SQL. And just by using the allowed list, that would be a bit restrictive, and it will be just the type of data. We can also sanitize the data itself. So we sanitize user input before sending it to the backend itself. So kind of another layer of security. We sanitize it on the front end. If something goes wrong, we don't send it even to the backend, or maybe we change the data in some way before sending it to the backend, and then on the backend, that first thing, the prepared statement, the parameterized queries, are used again as another layer of security, and that way, the most important thing of any web application, which is data, is secure. So that is how we do the SQL injection mitigation. Okay, next topic. Next topic is all about authentication. So when people hear authentication or authorization, they tend to think that it is basically the same thing, especially the non-native ones. But there is a precise difference. And authentication basically means that we verify user itself. So we answer the question who it is, and the authorization. It is usually after the fact, so after the authentication is done, we authorize that user who we know already to do something. So we answer the question what you can do. So I know who you are, but what can you do? And the authorization part restricts different parts of the application in terms of the user itself. Think of it as a access control, some practices that allow users to authenticate to the website, so use their username and password, for example, and then access a certain number of pages, but they cannot access the admin page because they will need another username and password, or even they won't even see that page in the first place. That is authorization. So the server is, before giving back that page or before allowing users to see something, it checks the if that user is authorized to perform some actions against that data. The server usually knows already that user. It allows the user to see at least something, but not everything. And authorization is answering the exactly what user is authorized to see. So then how do we do authentication or authorization? Let's start with the authentication first. There is a number of ways to do that, actually. Starting from the basic ones, cookie-based authentication, where we already mentioned that, where we kind of make our browser store some randomized or pseudo-random thing inside the browser itself, and then send it alongside every request. Token-based, where we generate that pseudo-random thing again, but instead of storing inside the browser itself, we store it in our application. It could be stored in the browser also, but the main thing is that it is not necessarily stored inside the browser itself. And then every time we need to do something, so like authorization, authorize the user to some kind of web part, we ourselves need to retrieve the token wherever it's stored, place it inside a specific header, and then send it again. So cookie is more responsibility pushed to the browser part, token, more responsibility pushed to us. That way we can kind of like decide what we need to do and what we can do. Third-party access, again, pushing responsibility even further from ourselves to some kind of third-party provider. We'll talk about them a bit in a second. Then there is something called OpenID and SAML. Basically two ways, HTTP and XML way of doing authentication, and it's usually the thing that is used to provide a single sign-on. Another term that we hear lots today. And single sign-on is imagine a huge application and that is divided into several different sub-applications, and they all require some authentication, and you sign up in one sub-application, then you go to another and you ask to sign up or sign in again, and it's a completely different application, but it's all under the same organization as Facebook or Google, etc., etc. So a single sign-on would be a solution that would share your authentication details across all the application inside that organization, so that you can authenticate into one application and have access to everything else. That would normally require you to authenticate. So, and that's all about OpenID as SAML. We also have something called one-time password, OTP, which is kind of self-explanatory. The website generates you a password and sends you that password, that pseudo-random thing somewhere. Could it be your phone, your email address, anything to be used for you to see that information that is specifically for you. Two-factor auth, also one of the topics, and that's kind of like a step up on top of everything we've mentioned already, where we need to have another way of authorizing the authentication process for the user. So it's like an extra step, an extra question that we ask the user to do. It usually revolves around physical world. So when we use user name and password in our website, we then ask user to, hey, we'll send you that one-time password, or we'll send you some kind of a link. Could you please go and use your phone, use your email address, use any other things in the physical world to tell us that you are who you are. So cool thing, but really complicated one, and a bunch of other more specific ones. What are the best practices? So that's a huge topic, so we need some best practices outlined. My personal and most of the people's personal best practice would be, if you need some authentication in your application, it is generally a much better idea to use third-party solutions instead of going through the long list of, on the left, of all the best practices and all the headache and all the responsibility that you will be facing if you decide to do authentication yourself. So a rule of thumb would be default to third-party solutions like Google, Facebook, GitHub, any other solutions that are kind of outlined whenever you sign in somewhere. You will see the two inputs like username and passwords for the sign in, and then, hey, sign up with Google, sign in with Google, sign in with Facebook or GitHub. That is a third-party solution. So they kind of handle all the overhead of handling your data, your username and password. They usually provide the single sign-on at the same time, so you can use your stored identity in Google, Gmail that you have already signed in to sign in into some new application that uses Google as third-party solution. And you won't even have to provide the username and password for Google itself again, because it knows who you are. So that's kind of like focusing on the application and business logic instead of focusing on something that literally all applications need to have, which is authentication. So for big corporations, for those who like the challenge, all best practices, apart from the third-party solution, could be use long salt and strong encryption. Might sound like a bunch of gibberish. However, if you dig deeper into authentication, if you decide to implement it yourself, you'll encounter the exact definitions of exact ways you can do the salting, the encryption, etc., etc. So just be sure to use the strongest and the longest of the one to be kind of like highly secured. Then use HTTPS and TLS only. Whenever you build a website, nowadays it's the best practice to have that HTTPS thing enabled. They'll mark you in the SEO of Google, so search engine optimization algorithms. And also from the security standpoint, by using HTTPS and TLS, you will be transferring those username and password in a secure way. So It is a mandatory whenever you use third-party solutions. Just be sure to look at the address bar and see what protocol they're using, and they'll most likely be using HTTPS themselves. So good thing to use in our authentication, custom authentication. Then sanitize logs and errors. That is mostly like a programmatic or software engineering best practice in terms of making authentication. Sometimes you forget the console logs that just output username and password. That can happen, especially in the long, big projects with lots of places. And it could be nested deep inside some object, and you won't even realize that it's there until you use some kind of third-party logging solution, and that logging solution will provide you with ways to open up all those objects and see, with every request you're sending some kind of username and password. That is a bad practice. So sanitize your logs for that kind of data. Errors also, you need to kind of stand in the middle of JavaScript that spits out errors, throws errors, and the actual output medium where those errors go, where it be, would it be like DevTools console or some kind of logging solution or Node.js terminal logs, anything, those errors should go through your processing before the output. So you need to, again, remove every username, password, etc., from the error messages. The stack trace also could sometimes be removed, at least for the production deployment. So be sure to look into the errors as well. Then make cookies secure, as we also mentioned already. If you use cookie-based authentication, you need to enable that HTTP only thing, because if you miss something in your security, be sure to provide your website with a script that will be just spoofing all the cookies using simple JavaScript web APIs calls, and that's it. Your users are compromised, and you won't be even sure how long they will be compromised, depending on your session expiry. And talking about the session expiry, you need to have that thing enabled. So apart from doing all the authentication and understanding who your users are, you need to invalidate that understanding when time goes by. So session authentication could be like 1 day or several hours, or I don't know, a tab closing session. So any time of session should be expired at some point, so that those hackers who got actually were able to spoof your cookies, your authentication ways, won't be able to use it for long. And lastly, not lastly actually, because there are lots of best practices, nitty-gritty details. But if you do implement the authentication yourself to have a secure application, you need to look into the two-factor authentication, because that's a really nice way to ensure that anyone who programmatically gets that security vulnerability exercised in your application won't be actually doing anything with the user data, because it just two-factor authentication would actually prevent them. They're not actually in the possession of phones, emails, etc. So that is a good way to kind of secure your application flow. Okay, and we're done with most of this stuff. You'll have nice links at the end of the presentation that were mentioned, and even more, especially these three, I believe, will be the most useful. They provide some examples of code in JavaScript, I believe, for all the security vulnerabilities that were mentioned. And yeah, now it's a good time to answer the question. So on websites that does not require logging Auth, how critical is to use secure protocol? Secure protocols are enforced nowadays. When they were invented, they were just a security best practice to use a HTTPS. However, today they're enforced, and they're enforced visually. Whenever you're using HTTP instead of HTTPS, anyone who accesses your website will see that nasty thing on the left of the address bar where it says this website is not secure. Some of the corporate networks would not be allowing traffic to that website based on that HTTP thing. And basically most of the browsers themselves, they analyze your website traffic and they decide if you're secure or not. So it is the best way from the user perspective to have that HTTPS also, not just security standpoint. Google itself will analyze your website and the protocol that you're using underneath to move you up and down in the CEO ranks. So it is nowadays critical. It wasn't in the beginning, but now it's critical, I think. So it will require some additional work. And once it's set up, it'll be like a no-brainer for the rest of the developers. They would not just use something like HTTPS whenever they do some requests. It'll be automatic, but it is critical from the security perspective, from the best practices perspective, from the algorithm and visibility. So be sure to use that. Yeah. Any other questions? Okay. Okay, so remember that that is just the basics of security. Security is a very vast topic. And just by going through those links that I mentioned is already enough for you to kind of cover most of the topics and try to implement the mentioned techniques, the mentioned best practices whenever you see whenever you program something. So yeah. Okay, thank you very much for your attention. I'll be seeing you next time. Cheers.